The joint distribution of two or more random variables is the function which tells you the probability of whether a certain condition on those random variables occurs. So for example, the joint distribution of two random variables, x and y, is the function f of a, which is the probability that the point x, y lands in A, where A is a subset of R squared, meaning A is a set of pairs of real values. So if x and y are discrete random variables, then each of x and y have a probability mass function, or PMF, and x and y together have a joint probability mass function, or joint PMF, P of xy, where the probability that the pair of points x, y is in a set A is the sum over all points in A of P of xy. And similarly for two continuous random variables, each having their own probability density function, the random variables have a joint probability density function, or joint PDF, f of xy. And the joint PDF satisfies that the probability that the pair of points x, y is in a set A is the double integral over A of f of xy dx dy, or it could be dy dx depending on how you set up the integrals. So let's look at a couple of examples. And these examples will not only show you what a joint PDF or joint PMF are, but also how they can be used to solve certain problems. So let's let x and y be random variables with joint PMF. The probability that x is 0 and y is 0 is 0.3. The probability that x is 1 and y is 0 is 0.1. The probability that x is 4 and y is 5 is 0.1. And the probability that x is 4 and y is 4 is 0.5. We want to find the probability that x equals y. So there are 2 points at which x equals y. Either x and y are both 0, or x and y are both 4. So the probability that x equals y is p of 0, 0 plus p of 4, 4, the two values at which they're equal. And we can plug those in from the given information. So that's 0.3 and 0.5, which sums to 0.8. So the probability that x equals y is 0.8. Now let's let x and y be random variables with a joint PDF, f of xy equals 4xy, for 0 less than or equal to x less than or equal to 1, and 0 less than or equal to y less than or equal to 1. And f of xy is 0 otherwise. We want to find the probability that x is less than y. So in this case, we're looking at the set A is the points x, y such that x is less than y. And if we were to graph this, we're only graphing from 0 to 1 in each axis. And this would be the line where x equals y. And this region up here in this triangle, this is where x is less than y. So the y values go from 0 to 1, and for any y value, we would take a slice here from x that would go from 0 to y, since this is the line x equals y. So when we set up the integrals, we're integrating from 0 to 1 dy, and then we're integrating from 0 to y dx of the joint PDF f of xy. So the probability that x is less than y is the integral from 0 to 1 of the integral from 0 to y of 4xy dx dy. Then you just do a standard integration. So integrating x dx is x squared over 2 from 0 to y, which gives you 2y cubed dy. And then integrating y cubed gives you y to the 4 over 4. And then you integrate that from 0 to 1, which gives you 1/2. So there's a 1/2 chance that x is less than y. Now if you're given the joint PDF, you can also find what are called the marginal distributions, or the distribution of any one of the given random variables. So if we're given a joint PMF, P of xy, of two random variables x and y, you can find the PMF of x by summing over all values of y. So the probability that x equals little x is the sum over all values y of p of little x little y. And similarly, the probability that y equals little y is the sum over all x of the probability that x equals x and y equals little y. So let's take this example that we saw above again. So x and y have this joint PMF function, p of 0, 0 is 0.3, p of 1, 0 is 0.1, p of 4, 5 is 0.1, and p of 4, 4 is 0.5. We want to find the PMF of x. Oh, and this is a typo. We already found the probability that x equals y above. So there are three values that x could take, 0, 1, or 4. The probability that x equals 0 is the probability that we get the point 0, 0, which is 0.3. The probability that x is 1 is the probability we get the point 1, 0, which is 0.1. And the probability that x is 4 is the probability we get the point 4,5 or 4,4. So we do probability of 4,5 plus probability of 4,4, which is 0.1 plus 0.5 or 0.6. So this little p function is the PMF of x. And you can do the same by integrating over the PDFs if we're given a joint PDF. So given a joint PDF of two variables x and y, we can find the PDF of x, where f of x is equal to the integral from negative infinity to infinity of f of this value x, y, dy. So we just integrate out the y value. Or to find the PDF of y, we integrate out the x value. So f of y is the integral from negative infinity to infinity of f of xy dx. So let's do one example of that. So let x and y have joint PDF f of xy equals 1 over pi if x squared plus y squared is less than or equal to 1. This is just a uniform distribution over a circle of radius 1. So we have a circle of radius 1, and x and y can land anywhere in here. Then we want to find f of x, the PDF of x. So x is going to be between negative 1 and 1, and f of xy is positive only if negative square root 1 minus x squared is less than y is less than square root 1 minus x squared. So using these bounds, we get for any value x between negative 1 and 1, f of x is equal to the integral from negative root 1 minus x squared to root 1 minus x squared, 1 over pi dy. And this ends up being 2 over pi square root 1 minus x squared. So the PDF of x is f of x equals 2 over pi root 1 minus x squared for negative 1 less than x less than 1, and f of x equals 0 otherwise, since there's a 0 probability that x and y land outside that circle. So we've talked about two random variables in general, but you can also have a joint distribution for n random variables. So given x1 through xn, the joint distribution is the probability that x1, x2 up to xn is in a set A for a subset A of Rn, or in other words, R points of R are real numbers. And if x1 through xn are continuous, and they have joint PDF, f of x1 through xn, then the probability that x1 to xn are in A are the n integrals over the set A of f of x1 to xn, dx1 through xn. The same would go for a PMF. You would just sum over all values, but it's not really multiple sums. You just sum over all the values in the set A of the n coordinates.